Welcome to this lesson. In this lesson, we are looking at commutative property. So when we say commutative, what we mean is that if you operate two numbers on each other and you interchange the numbers, you will get the same result. For instance, if we have 5 plus 4, then we interchange the position 4 plus 5, and we are able to get the same result as 9, then the operation is commutative. For instance, if we have 3 plus 4, then 4 minus 3, then we get the same result as 1, then the operation is commutative. So in terms of binary operations, what we have to do is that if we operate two numbers based on the definition, it must give us the same result. If we interchange and we get the same result, then it's commutative. So let's start. So let's say we have operation A, operation B as A plus B plus 2AB. So for commutative, A operation B should give us, when we interchange, which is B operation A. So let's call this side equation 1. Let's call this side equation 2. So let's pick the equation 1. So if you take the equation 1 side, which is A operation B, so it is definition saying that when you're operating on two numbers, it is the first plus second plus 2 times first and second. Now the first and second is what? A and B. So it will be the first plus second plus 2 times first and second. This is equation 1. Then B operation A. The first is B, the second is A, plus 2 times first and second, BA. Let's rearrange. A first, A plus B. A first, it will be 2AB, equation 2. So now let's compare term to term. Let's compare. So A is here, A is there, B is here, B is here, 2 to A, B. So it's the same. So since equation 1 is equal to equation 2, therefore operation star is commutative. So that is how we deal with binary operation commutative. So let's move on to other examples. So let's say we have operation X, operation Y, which is equal to X squared plus Y squared minus 2XY. We have to show whether or not the operation is commutative or not. So for commutative, X operation Y should give us the same as Y operation X. So X operation Y, let's call it equation 1. Y operation X equals equation 2. So for X operation Y will give us the same thing, X squared plus Y squared minus 2XY. So Y operation X, the first is Y, so it will be Y squared. The second is X, to be X squared minus 2 times the first, which is Y, times the X, which is second. So let's rearrange. So we are going to get X squared as first plus Y squared minus 2YX. So therefore, this is equation 2. Let's check term to term. Equation 1, which is this, is having X squared, equation 2 X squared, Y squared, equation 2 Y squared, 2XY, this is having 2SY. So since equation 1 is equal to equation 2, therefore star is commutative. So that is how we deal with it. Let's get more examples and see. Let's get more examples and check. Now, if we have another definition, P operation Q is equal to 2p plus 3q minus pq. We have to show whether p, the operation star, is commutative. So it will be p operation q should give us the same as q operation p. So here is equation 1. This side is equation 2. So for equation 1, which is p operation q, will give us 2p plus 3q minus pq, equation 1. The equation 2, which is q operation p, so the first is q, so it will be 2q. Then the second is p, so it will be 3p minus qp. So equation 2. Let's arrange the equation 2, so it will be 2p first, so 3p plus 2q minus pq. We arrange in terms of alphabetical order. This is original equation 2. So let's compare term to term, term by term. Let's compare. So equation 1, 2p, equation 2, 3p, equation 1, 3q, equation 2, 2q, equation 1, pq, pq. So they are not the same. So because they are not the same, since equation 1 is not equal to equation 2, therefore the operation star is not commutative. So it's very simple to look at the commutative. Let's take few examples. Let's say we have another question which states that the operation W operation R is equal to W plus R minus WR. And we have to show that 2 operation 5 is commutative. So for commutative, 2 operation 5 should give us the same result as 5 operation 2. So let's see. 2 operation 5 will be 2 because it's the first W plus R plus 5 minus 2 times 5. This one, the same thing, 5 plus 2 minus 5 times 2. So let's see. This will give us 7 minus 10. This will give us 7 minus 10. We are going to get negative 3 and negative 3. So since equation 1, since they are equal, then it's what? Commutative. So that is how we solve commutative. Always remember that for commutative, if you interchange the element and give you the same expression in terms of term by term in the final expressions, then it is commutative. If they are not commutative. So now we understand how to operate on commutative. When you interchange it, must be the same. So we have to solve more examples to understand. Thank you.